Hello, welcome back. Hi, Kendall. Can you hear us?
Hi, yes, I can hear you. Can you hear me?
Yeah,
Yes,
loud and
perfect.
clear. Welcome to the
Awesome.
show.
Thank you. Happy to be here. I appreciate it. Appreciate the opportunity.
Yeah, well, we're glad to have you. And yeah, from our new studio. So it's the first time in the studio. So yeah,
It's awesome.
yeah, yeah, it looks great. We're really proud of the whole team that created this studio. So big
Well,
ups for them. Yeah. So well, welcome. And yeah, we're happy to have you for your session. And of course, we also did a little background check on you. Investigated your bio a little bit and tried to find, well, the interesting stuff. And well, one of the things I noticed was that you did, you graduated, you did a study, management information systems,
Yes.
but also Italian, right?
Sì.
Yeah.
Imparato un po' italiano, ma non ma. It was many years ago, so
Oh, that
I
That
can't
that
do
was
a
pretty good.
lot, but yeah.
yeah,
So
that's more than I can pronounce. So kudos to you, Kendall.
Yeah.
yeah, so
Molti anni fa, that's how you say many years ago. I was actually pretty good at the time when I was living there, and I had a host mother who was about like 83 years old, and she spoke no English. So basically, anytime we needed to communicate, we had to go to the Italian dictionary and figure out how to say what we needed to say. So it was a good time.
awesome. So that's the reason. Yeah, and I also noticed that you are part of a podcast show, right? A co-host of a podcast show, and and,
Yeah,
and that's
yeah.
been
So
running for a
Azure
long.
Podcast.
Sorry, go ahead.
Oh, I was just gonna say yes, the Azure Podcast. So I've been doing that for I want to say almost 3.5, if not longer, 3.5 years.
Yeah, I noticed like over 400 shows already. So yeah, that's crazy.
We still have a couple of hours to do tonight
Yes,
to catch up on that one.
for sure.
Yeah, that's it's definitely one that if you wanted to listen to the whole thing, you'd have to really commit. You'd have to commit. And Azure has changed quite a lot since Sajid and the rest of the team kicked off the podcast. So I'm honored that they allowed me to join aboard and share some insights on that.
Okay, and then I still had one personal question before we let you kick off with the presentation. Because I noticed that you also have a part-time job as a cycling instructor. And this is the moment where I probably have to admit to the audience that I started picking up actually exercising on my spinning bike at home with the whole COVID. And as you can see, I probably can still use a couple of pointers to really kick off the workout. But how are you combining like the technical stuff and then also finding time to be a cycling instructor?
Yeah, it's a great question, and it's certainly been an adjustment. One thing that I find is when we're so engrossed in technology all day, it's really important to have those moments where you can just go move your body, be physically active, do something that gets you offline. So it's been a really nice haven from that perspective. But I also find that I love motivating and encouraging people and having them challenge themselves to accomplish something that they didn't think they could accomplish. And so if you come take a cycle class, you'll be yelled at by me a lot of words of encouragement, a lot of, you can do it. Don't give up on yourself. You can do more than you think is possible. And I think I try to bring that mindset into my job as well. So there is a little bit of overlap there, but it's always a good energy release at the end of the day.
Yeah, well, that's what I'm noticing with all the cycling that I'm doing in the morning now, that it's a great way to kickstart the day and just fully energized, be more focused on the task ahead. So, yeah, I fully
Absolutely.
understand the motivation part. So thanks for explaining that one.
Yeah, and I will say it's challenging sometimes because at the end of a long work day, you might be drained, right? I have days where I'm on video 6 hours and I've had meetings back to back, and then I have to go motivate other people who may be lacking some motivation when I'm in the same position myself. So that can be challenging at times, but I think just being human and letting people know authentically, like, hey, we've had a long day, but we're in this together is always really good.
Yeah, I think that also makes it more a team effort. So I think that's a good thing as well.
Yeah, and I don't know if you can see this, but my cat is asleep. If you look at the bottom of the camera, you might see him. He's passed out. So I hope that y'all find my talk today a little bit more entertaining than he does, because he's heard it a lot more.
Oh, I've been there where I tried to practice talks and just had my girlfriend and a cat on the couch. And I still feel very blessed that my girlfriend decided to stay on the couch, because halfway that cat just got up and moved out. And I saw the look on her face going like, oh, I wish I could follow you. Please take me with you. So yeah, that definitely motivated me to keep the talks interesting. So I'm pretty sure we'll be fine tonight, Kendall.
Okay, sounds good.
For sure, yeah. So I guess it's time for the session then.
Yeah. Looking forward to it.
Awesome. And okay, so everyone can see my screen. Great. I'm going to kick it off. Please feel free, to interrupt me on your end if there's any issues, or if you can't hear me, just let me know. But I'm going to jump right in if that's okay with everyone. So
yeah, perfect.
Thanks again for the opportunity. I'm super passionate about the work that we're doing for Azure Container Apps, and I'm really grateful anytime I have the opportunity to share that passion with others. I hope that you're as compelled by the work that we're trying to do as I have been joining the team. And just for a little insight into my background, so I've been at Microsoft for almost 6 years in July, which to me is absolutely wild to reflect back on. And as part of my journey, I've always been customer facing. I've always been in the field, whether it's doing consulting, contracting out to basically help other companies write applications. And then I migrated into what's called the Cloud Native Global Black Belt team at Microsoft, focused specifically on cloud native technology. So for a lot of us, cloud native, what even is that? It's such a buzzword these days. But I think, figuring out what that means to customers and helping enable their journey as they migrate to the cloud, and to just architect their applications in a way where they can really take advantage of the benefits of what cloud provides, from an integration perspective, from an extensibility and performance perspective. And one of the big movements has been toward Kubernetes. And I think we can all get a quick laugh in when we hear the word Kubernetes, because it's just tossed around so much and we all have different thoughts and opinions on it. And maybe some of us are in earlier stages than others in terms of the Kubernetes journey. And as you get deeper into that journey, you'll realize that there is a lot of overhead and operational complexity when it comes to managing Kubernetes at scale. And so that's a lot of what my team, or the Cloud Native Black Belt team, really focused on, was how do we help alleviate some of those architectural decisions and complexities by providing best practice guidance and solutions for customers. And so I'm bringing all of that knowledge into the program management role, or a product management role, that I now serve on the Container Apps team. So I joined the team at the end of November, early December, and have been trying to marry all of that customer feedback and all of that customer experience in a brand new way, which is how do we take some of these learnings and really drive a great product experience for customers. So that at least provides a little bit about my motivation, why I love this role, and why I'm so excited about this product and helping enhance customer experiences. So what is Azure Container Apps? If this is a new concept for you, or if you haven't heard of the service, this actually went preview at Microsoft Ignite at the end of 2021. So it's been in preview now for several months. And if you've played around on the Azure platform, which I assume most of you have, in that you're joining the Azure Thursday, live stream here, one of the things that Azure has done really, really well is providing great platform as a service hosting options for your applications. So Azure App Service is such a great platform, has such tight integration with other services on the Azure platform, and to me really enables customers to take things one step deeper. It's not just about migration, but truly how do you modernize your applications, and how do you offload some of the responsibilities that make running applications challenging for developers, and allow the platform to handle some of those concerns. And so we've played really well in this platform as a service space. We have great functions as a service through Azure Functions and other serverless type of hosting options. Even Cosmos DB, for example, provides a serverless or consumption-based hosting capability. And then obviously we have our managed Kubernetes services. So we have Azure Red Hat OpenShift, we have Azure Kubernetes Service, both of which are really great platforms for helping reduce some of that operational complexity that Kubernetes provides. So where does Azure Container Apps fit in, right? We already have all of these great offerings. Where we really felt like we had an opportunity to cater to a wider range of customers is providing that PaaS-like experience on top of Kubernetes so that customers can run microservice-based applications in containers without having to necessarily think about all of the operational overhead that they might need to plan for if they needed something like an Azure Kubernetes service. And frankly, there are going to be specific scenarios that I think are really good use cases to fall on the spectrum of our offerings. But where I think Azure Container Apps really is aiming to provide is bridging that gap between app service and AKS and providing a more PaaS-based microservice hosting option on top of Kubernetes. So we're built on top of open source, obviously, because we are powered by the Kubernetes platform underlying from an infrastructure perspective. But the nice thing is customers don't have to worry about some of the things they would, like upgrading the infrastructure or doing Kubernetes API updates. We really manage that on the customer's behalf. And our goal is to eventually come to a place where if a customer needed to get app portability and they wanted to port into an open source instance of Kubernetes or even AKS, they would have a really good opportunity to take their container apps workload and find a way to get a more streamlined migration path. And so that's something that we're really working to get feedback around, and we're investing in tooling and ways that we can enhance that experience. So I want to talk a little bit more about the underlying open source integrations and some of the capabilities that those open source integrations provide. So one of them is being able to get flexible scale with these kind of serverless or consumption-based containers. So when you think about Kubernetes platforms, traditionally you're going to provide a certain number of nodes within a Kubernetes cluster. You're going to scale those nodes. You're going to scale pods on top of those nodes in order to extend that workload and scale based on whatever particular metrics might be most relevant to you. So what we've done inside of Azure Container Apps is that we actually provide not only the ability to scale your containers based on HTTP, but also any event-driven autoscaler that's supported by KEDA. And KEDA is the Kubernetes event-driven autoscaler. So it's an open source project. It's something that can be leveraged today on AKS. So if you wanted to deploy it via Helm chart, or even they're working on a KEDA extension, there's some great tooling out there that's already very much adopted in the Kubernetes ecosystem. And essentially it works alongside of the horizontal pod autoscaler in the Kubernetes cluster and extends that capability so that you can get a more event-driven scale. And this is really neat because we built this directly into our platform. So customers don't have to worry about the management of KEDA, the versioning of KEDA, the deployment of KEDA, anything like that. And really, they don't even have to know much about the fact that it is KEDA, other than we're in line with documentation and implementation schemas that KEDA provides to you. So what KEDA enables within our container apps environment is that we can actually give you a native scale to zero capability. So if your application workload falls below a certain threshold from a traffic and CPU consumption perspective, we can then scale your application workload down to zero and essentially charge you nothing. So unlike Kubernetes, where you're really thinking more about the charge for the base compute, right? Whatever node you might be using, or like the compute SKU. Instead, when you think about our model, which is more serverless, you're really just being paid based on that consumption model that's more similar to Azure Functions. And what's neat here as well is that we actually provide the ability for you to run containers in what's called an idle mode. So most serverless platforms typically have a cold start, and we mitigate that by allowing customers to run a certain number of minimum replicas, similar to how you can do that inside of a Kubernetes cluster, but we manage it on your behalf. So let's say, hey, I want to have 5 instances of my application running at all times. Instead of scaling you down to zero and paying no cost, you'll scale down to the minimum number of replicas. And then once that traffic and CPU threshold that we've documented is hit, we charge you only an idle fee, which is a smaller rate than we would pay for an active container app that's currently, taking traffic and scaling based on CPU. So that's one of the things that we provide. And once again, we are in line with CADA open source. However, we are still working to document any potential edge cases or capabilities that we don't currently support. So definitely stay tuned for, hey, I tried this CADA scaler. It didn't operate as expected. We would love that feedback, and we want to make sure that those edge cases are documented well for all of you as we move toward a GA date. Another aspect is really focused on, okay, now that we've abstracted the infrastructure away and we're providing this serverless capability, how else can we enable developers to truly leverage this platform to build microservice-based applications? So we've integrated another open source project into our platform, and that is called Dapper, or the Distributed Application Runtime. So by having Dapper enabled, customers can essentially offload a lot of the typical microservice-based plumbing code that they would bring into their microservices to an application sidecar for Dapper. And so instead of, for example, I'll give you a quick example here. Let's say that you're using Azure Service Bus because in distributed applications, you want to decouple communication as much as possible. So I might have microservice A communicating to microservice B, and I want that to happen in a resilient way so that if microservice B was to go down and another instance was to spin up, it could obviously go to that topic and retrieve that message, like some kind of dead letter queuing, like all of these capabilities, right, that you might not get if you just do direct service to service invocation. So let's say that you have Azure Service Bus sitting between your microservices, and instead of bringing the Azure Service Bus SDK and plumbing all of those applications to publish and subscribe to Azure Service Bus, instead, you can basically define some configuration and apply that within container apps. And what that will do is say, hey, instead of calling through the Service Bus SDK from the application code, I'm going to have my application code call the Dapper sidecar through an HTTP or gRPC endpoint. It's going to say, hey, I want to publish a message to a Azure Service Bus topic or queue. And then the Dapper sidecar will actually handle all of that connectivity and the publishing of the message. So it super simplifies a lot of those microservice-based requirements that typically app developers have to be really knowledgeable about and start bringing into the application code, which sometimes takes away from the core business logic. So that's what Dapper does in a nutshell. So we do provide that capability so you can easily inject a Dapper sidecar into your application and take advantage of some of the capabilities Dapper provides, which I'm happy to talk about more, and hopefully we'll have the chance to demonstrate a little bit today as we progress in the presentation. And then another thing to call out here is that we're continuing to enhance and work on what our code to cloud story is going to look like for Azure Container Apps. So obviously one of those is going to be GitHub Action integration. So being able to easily create new container apps in an automated fashion and integrate into CI/CD processes that you might already have within your organization. And then we're also working on ways that we can create local tooling experiences through Visual Studio and Visual Studio Code that will help you to get a better development experience and connective, interactive experience with the container apps instance that's running in Azure. And then the last point that I really want to touch on here is, in addition to these open source projects that we've provided, we're also incorporating Envoy and managed ingress into our platform. So what's really nice about this is through the managed ingress capability, customers no longer have to wonder how they can expose an endpoint publicly to external consumers. Instead, they can basically just define, hey, I want ingress to be enabled for a particular container app. I want that ingress to be either within the container apps environment where only other container apps can communicate with this, or I can expose it publicly, to the internet, and we'll actually generate the default domain. We'll assign an FQDN to that particular application and make that consumable via Envoy. So through this capability, we're also enabling the concept of what's called revisions, and what this allows you to do is essentially make intentional changes to your container app that's deployed. And think of a container app as a single microservice within your overall application architecture. And so if I make a couple of changes to a particular container app, I can trigger the creation of a new revision, and I can get traffic splitting capability enabled through Envoy, where I actually enable some A/B testing scenarios or blue-green deployment scenarios. So we're continuing to flush out exactly what revisions will look like and how we will be able to help customers use this feature for as many relevant scenarios as possible. So stay tuned on this as well. So last but not least, before I dive in a little bit deeper, and maybe I'll pause for questions just to make sure that I don't miss anything. What can you build with Azure Container Apps? So when you look at our main goal for the service, microservices is certainly a first-class citizen within Azure Container Apps, and we're really trying to optimize our platform to allow you to deploy your microservice-based applications and get great communication, especially using some of the neat capabilities within Dapper, should you so choose, right? That's not a requirement by any means. We have the event-driven processing, which is really enabled through Kata and the ability to monitor these different event sources and then trigger application work to take place based on that scale. We have web applications. So if you wanted to run your web apps inside of container apps alongside of your microservices, we're providing capability like custom domains, managed certificates, bring your own certificates, and integrated authentication. So these are things that are currently in the works and that we've committed to on our public backlog. So bring your own certs and custom domains. So hopefully we should see that feature released fairly soon. We also have obviously public API endpoints or just internal API endpoints that you would potentially use the concept of revisions with and do traffic splitting. And then we're also really looking into background processing. So making sure that if you have long running background processes that we don't enforce timeouts, but those can continue to run and you can be successful running those workloads inside of container apps. So before I continue and talk a little bit more about what you can expect from an environment and container apps perspective and what it looks like and get into a demo, I'd love to pause here for any questions. So I'll stop talking now. Does it look like we have any questions from the live stream? I might not have a perfect view of that, so feel free to surface those up if there are any. Let me see here. Can everyone hear me okay? No questions. Okay, cool. I see now. No questions at the moment. Sounds good. Then we'll keep going. Okay, let's progress. So let's talk a little bit more about the actual container environment and what this looks like if you were to go do a deployment. So we have a concept within container apps of a container app environment. So you can think of this as the grouping of multiple container apps that are related. So you would deploy multiple related services within a single environment. If you want to deploy applications to the same virtual network, that's another great reason to deploy them within the same environment. And then if you're using things like Dapper, if you want applications to be able to communicate using Dapper service-to-service invocation, or if you want them to share a Dapper configuration, that's another great reason to deploy to a single environment. And another thing that we provide is we do logging within your environment. We obviously stream logs to log analytics within Azure. And we're also working on some capabilities for log streaming directly from the container app itself, where you can immediately see those logs instead of a small delay when exporting to log analytics. So if you want those logs to be aggregated and visible in a single place, you can share an environment. Some of the reasons why you would not want to deploy to the same environment is if you never want two applications to share the same compute resources, or if you want to ensure that applications cannot communicate with each other through Dapper, then that would be a good reason to potentially create a second environment there. So environments really provide that observability and network boundary for a set of grouped or related container apps. And then I want you to think of each container app as a microservice. So, container app 1 might be the order service, container app 2 might be the inventory service, container app 3 might be the pricing service, whatever that might look like, right? So it's really more of an application concept. Within a container app, we also have the concept of revisions, which I mentioned earlier. So let's say we have, an order container app, and then we could have revision 1 of that container app and revision 2, even potentially 3 or 4, that are all going to be dictated based on, incremental changes to that container app that you can get that A/B testing or, traffic shifting to. And then within the revision concept, we have the concept of, I don't like pod here. I should have updated that. That should really be replica. So you'll think of a replica as being an instance of a revision. So if you think about the scaling, for example, I might have 5 instances of revision 1 that I want to run, and I might have 10 instances of revision 2 based on my scale rules. So that's what the pod or revision concept is. So hopefully that, pod or replica concept. So single order service with multiple, revisions, and then each of those revisions has the ability to scale to, 0 to many instances. I think I did a pretty good job touching on all of these concepts, actually. So I think we can probably continue moving forward. But there are a couple of things I do want to call out. So from a container perspective, we support Linux at the moment, Linux-based container images. So if you're looking to run Windows containers, it's not currently supported on container apps today, but would love to hear any feedback. If that's a highly requested feature, then we'll definitely evaluate that down the line. We can support containers that are coming from any public or private registry. And then, we're not allowing customers to run privileged containers or processes that require root access. So this is something else to consider. There is no required base container image that we make or enforce you to specify. And if your container app was to crash, we obviously handle the resiliency of those on the back end. And we do support the sidecar model. So if you did want to run specific containers together in a pod or a replica, you would use a container as a sidecar to your primary app. If you were potentially wanted to share scale rules across a couple of different applications, but it's typically going to be a single application container and any supporting additional capability like a logging or exporter or something like that enhances the overall capability of the initial application. Okay, awesome. So we've talked about environments, we've talked about container apps, revisions, we've talked about managed envoy and the traffic splitting capability. So at this point, I'd love to talk to you a little bit about a bit of a real world scenario. I think we have 30 minutes left, so we'll get into it just a little bit. And once we do that, then we'll come back and talk a little bit about some recent updates and announcements, a little bit about some roadmap items, and then we'll pause again for any additional questions, hopefully with 8 to 5 minutes left in the call. So one of the things I want to call out a little bit is our Dapper integration, because the application concepts that I'm going to be showing you today actually leverage Dapper. So as I mentioned, Dapper is an optional capability within container apps that you can leverage. And it's an open source project that we have brought into our platform. And essentially what it allows you to do, as I mentioned, it helps you to build resilient, distributed, event-driven microservice-based applications. So Dapper itself can run on premises, in the cloud, on edge. So we brought that into our managed PaaS platform. So through this basically set of APIs, you can easily write distributed applications that run as, and the Dapper sidecar will run as that sidecar process next to your core container app application. And what we support today inside of container apps is service-to-service invocation, state management, pub sub, resource bindings and triggers, actors. We support observability, but essentially the observability bit is all about distributed tracing. So what we enable you to do is pass in an application insights instrumentation key when you deploy your microservices. And this will allow you to kind of see which Dapper services are communicating with each other, what the API calls are, all through App Insights. We don't currently have support for Dapper secrets. Instead, we have our own secrets implementation through container apps. So luckily, you can use the two very well together. So if you have to define any kind of secrets for your application to use or for your Dapper components, you're able to do that via Azure Container Apps secrets. So let me show you the application architecture of what I'm going to walk you through today. So here's our overall application architecture. So as I mentioned, within container apps, we provide that managed Dapper support. And then we'll have each of our respective container apps represented by these hexagons. I think that's a hexagon, or is it an octagon? I don't know. You can correct me in the chat. I think maybe it's an octagon. It looks like it has four here. So each of those, blue octagons or hexagons, LOL, is going to be a different container app. So those are the logical microservices that are in your application. So we have an order service, which is going to be our entry point. So customers can come into our, it's called Red Dog. That's the name of the sample that we put together on my on the cloud native team that I was formerly on. So you can come in and basically order medicine. So it's a virtual pharmacy. So a user can come in, a user can place an order, and then that order will then go through the Dapper sidecar to Azure Service Bus. In this case, is the implementation we chose. And that order will be placed on a pub sub topic. Like I said, this will be Azure Service Bus in our case. And then we have 4 subscribing services. We have the make line service, the receipt service, the loyalty service, and the accounting service. All of these have their own Dapper sidecars, and those Dapper sidecars are wired up to enable communication from the pub sub topic. So the make line service, and this arrow right here should be right here to the Dapper sidecar. So I apologize there. But what you can see is when a new order comes into that topic, each of these respective services has different actions it's going to take. So the receipt service will generate a receipt for the order. The loyalty service will calculate loyalty points for the new order. The accounting service will aggregate some data about recent orders over the past 10 minutes, orders over time. And then the make line service will put that medical order, like for a couple of medications, into a virtual queue, and that virtual queue will essentially be shown on the user interface in order to show us which orders are currently being processed. So the virtual worker and virtual customers are 2 container apps that are running internal to the environment. The virtual customer is just placing a series of orders continuously to generate traffic. And then the virtual worker is essentially running on a cron job, so that every 15 seconds or so, it can look at the make line and complete a new order or fulfill an order for that was placed. So that's essentially the overall application architecture that I'm going to show you a little bit about today. So without further ado, I'm going to stop sharing just for a second and pull up the associated bits on my local machine. So just give me 1 second here. And feel free, if there are any questions, just let me know while I'm pulling this stuff up.
Okay. So can you hear us, Kendall?
Yes, I can hear you.
Great. So there were some questions actually. So just a bit earlier, we were a bit too late to answer, but if you want to take them now, that's fine.
Sure.
So one question is about the web applications. You mentioned that there was something in preview there. I think bring your own certificates, or is the whole web application still in preview?
So you can run web applications in container apps today, but if you needed the really kind of what we feel enables web scenarios, which is the custom domains and bring your own certificates, those are still features that have not yet shipped. So we've committed to them. We're working on them. And we're, allowing customers to, we're letting customers know that it's coming. So they're not in preview today, but they will be available soon within the preview service altogether. So yeah, you could run a web application, but typically for that scenario to truly be supported from our perspective, there's a few things that we're still shipping.
All right, thanks. So yeah, that's one for now. I will save the other one for when your session is done. Is that okay?
Okay. Yeah.
All right.
Sounds good. Okay, I'm going to reshare my screen here. We're going to look at Visual Studio Code. So let me know when we're good to go here, and you can see.
You can see your screen.
Perfect. Okay, I'll zoom in a little bit here just to make sure that it's visible to everyone. Okay, there we go. So I'm going to clear this off. So we've covered the application architecture, right? So here's my actual code repository with all of the respective container apps that I showed you before. And I'm not going to go too much into detail because I think it would be a little bit too verbose for what we're trying to accomplish today. But what I will just show you is sort of how Dapper is working, and then I'll show you how these services can actually be deployed to Azure Container Apps. So let's take a look at the order service, for example. I have an order controller. And what this order controller is essentially doing is using Dapper in order to create and publish orders. So you can see here, I'm using the Dapper SDK. So one of the things Dapper provides is the ability for you to use either just HTTP or gRPC endpoints, or you can actually use the Dapper SDK, which makes writing your code a lot with Dapper a lot simpler, just because the SDK abstracts some of the the insides the innards of Dapper for you and provides a lot of capability in handling. So we use the Dapper SDK for C# in this case. And what you'll see is when a new order comes in, we actually just use the Dapper client that we've instantiated, and we use this method for publish event async. So what we're passing in here is some details about, at this point, we don't have any code for Azure Service Bus in our application, right? So like, how does my app know that we want to use Azure Service Bus if we don't have any Azure Service Bus references inside of our application code? So this is where I'm going to demystify this a little bit. So we have the pub sub name, which when I roll over it is reddog.pubsub, and I'll explain where that comes from in just a second. We have the order topic, so we have the name of the topic that we want to publish this order to, and then we actually have the order summary object, and this is essentially just going to be an order summary that we create based on the post, right? So if I post for a new order, I'm going to take that order object in, and I'm going to create an order summary that I then put onto the topic for my consumers. So that's what it looks like from this perspective. So we know that this pub sub name is meaningful when we use it here, and we know that the topic name is meaningful. So I'm going to show you an example of one of the subscribers. So MakeLine, for example, is a subscriber to the order service. And what we can see here is we have this endpoint, and this endpoint says HTTP post orders. So when a new order comes in from that Dapper mechanism, I have subscribed in I believe it happens here in my startup config. Let me see if I can find it here. Yeah, we can see here. So we can see that we're adding some Dapper configuration in our code. And then we also have this endpoints map subscription handler. So this is an important point that I want to call out. So we are actually using the Dapper SDK, and we're using the subscription handler in order to wire up when an app needs to be a subscriber to a particular topic. So that's what's happening in the MakeLine controller. Basically, that order is going to come here. So we see topic is pub sub name, so reddog.pubsub. So we remember this name is meaningful, right? Because this is the pub sub name that the order service is publishing to. And we have the order topic. So through this annotation on this method, this is how this method will get triggered anytime a new order is placed onto that topic. So very easily, I have now configured my app to use Azure Service Bus without using any Azure Service Bus dependency. What's even cooler here is that I can switch out the component implementation. So I can say, hey, I don't want to use Service Bus anymore. I want to use Redis streams, and I can keep all my code the same. I can keep the component name the same even, and all I would have to do is change the component. I would have to change the details of reddog.pubsub. So let's take a look at reddog.pubsub and what that actually is. So we can see here, this is our container app deployment. So, and I might actually have the components in I have my code repo and my infra as code repo separated, which is just a preference. So I think I have my Reddog. Did I close that out? 1 second, let me pull that back up. I think I might actually have my components here. Give me just 1 second. I want to see if we have our components in this repository. I'm going to show you them in 2 different formats. .pubsub. Yes, here we go. Okay, perfect. So this is what a component actually looks like. I just want to show you this really quickly because I think this is valuable. So we can see here that we have a YAML file, and it looks like maybe my screen's a little delayed. So I'll give it a second to catch up. Maybe it's just delayed on my end, but I'll just give it a second here to catch up. So what I did is I found our, can you all see my component screen? Can you all give me a quick confirmation? Can you see the component? Or is it still lagging? Hopefully you can see it. I'm going to wait until it catches up on my end. Okay, it's caught up on my end, so you should be able to see it. So if you
there's
see
a
here,
slight delay in the feed or in the stream, Kendall. So sorry for not catching up sooner, but we can see the component. Thank you.
Okay, perfect. Just want to make sure. So I just want to call out what a component actually looks like. So if you remember, the name was reddog.pubsub. So I specify that there's a component called reddog.pubsub, and then I have a type. So this type is going to tell Dapper the type of component implementation is going to be Azure Service Bus. If I switched this out and said pubsub.azure.redis, or if I wanted to even use another cloud provider, right? GCP has options that are available. There are a ton of different component implementations that you can switch out for. So I'm using Service Bus. I provide some metadata, which is basically the connection string. So I securely create that via a Dapper secret. And like I said, we don't support native Dapper secrets, so I'll show you what it looks like in container apps. But we just need to give Dapper the ability to connect to that particular PubSub mechanism. And then we create these scopes to show which services can actually leverage that. And I think we have some customization here that adds, a couple of other features. See, here's an example of a different one, which is called pubsub.rabbitmq. And if I wanted to switch out the component implementation to use RabbitMQ instead of Service Bus, I could just create a different component and give it a different name and switch out that name, and voila, my app is working. So I'm going to show you what this looks like in container apps. So I have bicep files. This is just the infrastructure as code approach I'm using. We support bicep, ARM, Azure CLI commands. We're working to support Terraform before GA. So these are just things to be mindful of. I just happen to be using bicep. So let's take a look at what it would look like to deploy the order service. So here's a bicep template that's been created to create a container app, based around that order service microservice within a container apps environment. So I specify the container apps environment, or the kube environment ID. So this is just basically going to be, hey, deploy the environment first, retrieve the ID, and then I want to deploy this particular container app to that environment. I'm passing in some information about the container itself. So in this case, it's called order service. And I've already, imagine I have a CI/CD pipeline that has, anytime I'm making modifications to the order service, it's obviously going to go and run an automated CI/CD process that builds the new container image and pushes it to a registry. In this case, we're using GitHub Container Registry, which is a public registry. Then we're going to give it scale. So do I want this container app to scale to 0? Do I want to set minimum replicas maybe to 5 because I know baseline traffic is going to be high and I want to avoid incurring cold start? So I could change that to minimum replicas of 10 or 100 based on whatever your baseline load testing indicates. I can also provide some information about Dapper, right? Do I want to enable Dapper? The answer in this case is yes. I'm going to give it an app ID for Dapper to use. I'm going to give it an app port, which tells Dapper what port to talk to to communicate with my application on. And then I'm going to pass in the components. So you can see here, this is where that reddog.pubsub service bus component is defined. And I'm passing in a connection string for connecting to service bus. And then, how is that actually getting populated? I'm actually creating a container app secret, which has a name of service bus root connection string. And here, because we're using bicep and infrastructure as code, we can actually go retrieve that primary connection string after we do the deployment of service bus. So we would deploy the container app. When we think about infrastructure as code, obviously we can define dependencies and what we want to be deployed first. And then we can basically retrieve certain parameters from those deployed resources. So that's what's happening here. What's really cool is, let's say we wanted to take a step backward, and I can just show you this quickly because I have it, and why not? I would love to show y'all. If you wanted to go way more simple and you say, hey, I just have a basic API, I'm trying to get it up and running in container apps, you could obviously go deploy that via the Azure CLI. So we have great Azure CLI documentation, but we also have a YAML manifest that you can use. So for example, I have a C# API, super basic, and I created a C#.yaml file. And I basically have the ability to specify, and I'm giving you my registry password, so I'm gonna have to go change that. So don't DDoS me. Let me go ahead and I'll delete that for now. So I provide some information about, in this case, I'm deploying a container app called Weather API to a specific resource group in a specific environment. I'm setting up connectivity to Docker Hub. I'm specifying ingress. Do I want to expose the API externally? In this case, I do not. I'm actually using VNet integration, so only other callers within the VNet can use it. But then I'm still doing, some of the same things, right? Passing in the container app, the image, the name of the container, any resource constraints. I'm giving it some scale rules. And in this case, I'm using an HTTP scale rule that says, hey, once I hit 100 concurrent requests, I want you to scale out to another instance of my container app. So this is just like, I just wanted to let you know there are other ways to interact with the platform. The way that I'm showing you is a little bit more enterprise grade. So I have a specific bicep file for each of my respective apps. And then I have my overall deployment, which also deploys, the other supporting resources for the application architecture. So at this point, we understand kind of what the order service is doing, how Dapper is working. We know that there are subscribers that we want to communicate with the service bus instance to retrieve those orders. So now I'm just going to show you what it looks like. So I ran the script. I have it running in the Azure Portal. I'm going to stop sharing my screen just for a second, just because I want to make sure that I pull up the correct. It's a hexagon, by the way. Thank you, Paco. I was really struggling there, wasn't I? That's how you have a bit of a noodle brain sometimes when you've been talking too much. So yes, the hexagons. Thank you for that. So I'm going to pull this up and I'm going to reshare my screen. The only reason I'm not sharing is I just want to make sure I navigate to the appropriate place and don't share any resources that might not be something I want to share. So just give me 1 second. I'm going to show you what the portal experience looks like. Now, one thing I do want to call out here is that we are a preview service. And with being a preview service, there are changes that we're making to enhance the experience based on iterative feedback that we're getting. So, for example, right now you enable Dapper within a container app spec, and you provide the components within a specific container app. One of the changes that we're currently making is providing the option or the ability for your container apps within an environment to share components. So for example, if my order service is the publisher to my Azure Service Bus instance, and I have 3 subscribers, they all most likely will use the same Azure Service Bus instance. So in its current iteration, you'd have to copy and paste that config into four different container apps. So what we did is we moved it up a level. So now I can define one component for Azure Service Bus, and it can be shared across those container apps. So that's going to model more of the open source implementation, and that is something that we've recently implemented. So you'll see that change trickle into the product. So I do want to be conscientious of the fact, it's not GA for a reason. We're making improvements and modifications to enhance the experience, as we go. So the app is pulling up right now. I am just pulling up the user interface. What I'll do while I'm here is I will walk you through some of the resources that actually got deployed. And then after I show you a couple quick things here, I'm going to flip it over to share a couple more slides on updates, because I think that those are relevant, and then I'll leave 5 minutes for questions. Okay, so I'm just going to put these into a bit more logical grouping here. Hopefully you can see the Azure Portal. So I see some supporting resources I've created, like the Azure Cache for Redis. I've created a Cosmos DB. I have my container apps environment, which hosts my container apps. I have a log analytics workspace, which is where all of my log streaming is being output. I have some other resources that are supporting my application. So we can close those for now. So what you'll see is all of those respective microservices deployed as container apps, and they're all within the same container apps environment. So one of the cool things is, like I mentioned, we have that App Insights integration for Dapper. So we could get some tracing and telemetry, see what's going on. So you see I have over 7,000 requests that have come in just today. I can see server response time. I can show data over the past 30 days. If I look at my application map, which is something that I love taking a look at. Ooh, no, hopefully this will load. Let's see if we can. It would be too good if the demo gods gave me no issues. Oh, here we go. Okay, so we see here that we have a couple of instances of our application running. We should be able to see traffic actually flowing from these. There might be an issue that's okay, there we go. That's much better, right? So we can see an application map of all of those microservices that are running in that same shared environment. We can see the number of instances. So right now I'm not scaling, which is fine. If I click in here, I should see the order service is actually calling local. This is to its local Dapper sidecar. I can drill in and see some information around the API calls, the performance, the number of calls. I can zoom in on certain ranges. So we get some cool information here just in terms of creating some App Insights integration. Hopefully my application is not going to give me too much grief and it's going to load. Oh, perfect. My application is loading. Let's keep our fingers crossed and see if it populates with some data. it's a little slow on my end because my computer is running a little slow. So we'll see. Oh, perfect. Okay, it's coming. It's coming. So as this is loading, what we can see is we have our order queue, which is orders that are being prepared. We can see orders over time. That's coming from the accounting service. Sales and profit also coming from there as well. And I apologize, it would be a little bit more dynamic if my computer wasn't running quite as slow. But this is at least our front end user interface that's providing some insight into all of those container apps that are running into the environment. And what's nice here is that I'm not exposing any of those other API endpoints running in the container apps environment externally, right? I can basically create a single point of ingress, and I can say, hey, only one point of ingress is enabled, and all of the other container apps are isolated within the environment itself. So we can see that the orders are coming in and that those virtual customers are placing those new orders, and the virtual workers are obviously consuming and creating, and outputting those. And we're seeing that dynamic aspect here. So that shows you a little bit what's going on. We are working to enhance a lot of our portal experience right now. So I'm not going to walk you through exactly what it looks like in the portal, just because I think we're going to be making a lot of modifications in the near future. So I'd like to pivot back, cover a couple more important things from a slide perspective, and then we can take any questions that you might have. So we're going to play it here. Let's switch this over. Okay, so one of the most recent features that we released is the Bring Your Own Virtual Network feature. So for customers who need network isolation and want to have the IP addresses for container apps and for their environment coming off of their Azure Virtual Network, we now support that. One of the nice things that we provide is a single static IP address for your environment. So that's really nice, because if you need to integrate, obviously, with like a firewall, or if you want to lock down that IP address or that externally exposed endpoint, you can do that now. I put together a blog post with the help of my teammates, so I'll make sure that you can access that. Hopefully you can access that. I'm not sure how I can drop links here, but at the minimum, you can just search through the Microsoft Tech community. That's where this is posted. If you type in Azure Container Apps Virtual Network Integration, it should pop up for you in Google or Bing. So this will give you a good idea of what we've implemented, and we're still working on documentation around ways that you can lock down your container apps environment if you're using like Azure Firewall. What are the ports, what are the FQDNs that I need to enable in order to make sure that the service is still functional? So those are things we're working on. I have a quick demo here that just shows sort of how this works in theory, or not in theory, but practically. So basically going through creating an Azure virtual network, creating a couple of subnets. So essentially you'll have a subnet that you can specify. That's where the control plane components for container apps will get their IP addresses, along with any of the apps that are running in the environment. Then I can create the environment with this internal only flag, which is what's going to lock it down to that single static IP address. And then we get a default domain for our environment. So until you can do bring your own domain, we provide a default domain. And then what I recommend is basically you can set up an Azure Private DNS zone, which is going to take that static IP address and the default domain. And essentially, any traffic that's destined for that default domain, you can then send to the static IP address in order to do resolution. What I'm doing here is I created an Azure VM inside of a subnet in the same virtual network. And then I created a container app that has an external endpoint. Now, external in this case means that the application essentially is exposed to other callers on the VNet. And unfortunately, my talk track didn't line up perfectly with the demo, so I apologize. But the point is, when you externally provide an endpoint in a VNet integrated scenario, that means other callers within the VNet can access it. So you saw when I made that API call, I was able to hit the endpoint. If I was to update that and change it to internal, and then I try to curl the endpoint, my VM can no longer communicate with that container app because I've made sure that it's accessible only within the environment. So the two levels of accessibility would be intra-environment accessibility, and then that second one would be, if we look here, the VM can call the endpoint because I exposed it externally to other callers in the same VNet. There is no public IP though, right? Like there's no public endpoint. So if you do VNet integration, you can't make it accessible from the internet. Whereas, in those non-VNet scenarios, if I expose it externally, that's to the public. And if I do it internally, it's to the environment. Okay, cool. Another thing that I wanted to call out, we are making a pretty big change. This is an announcement that we have on our public backlog, but we're doing a namespace migration. So this will impact the CLI and any bicep or ARM templates that customers might be using today. So I just wanted to put that out there in case you already have some great demos. You can go ahead and migrate to change that over from Microsoft.web to Microsoft.app. And then you'll need to re-register with a CLI, the CLI that uses this new namespace. So this is more of a backend change, but it is going to be a breaking change for customers, which we want to do all those breaking changes while we're in preview. If you're interested in some of our roadmap, we have a public backlog on GitHub. And if you go through our issues and just say label equals roadmap, that's where any item is tagged that we've already committed to doing. So whether it's VNet integration, custom domains, managed identity, better logging experience, Dapper support for gRPC, Visual Studio Code extensions. We're going to think about lifting, or we will be lifting quotas. Like for example, right now you can only run 2 environments per subscription, but all of these are just preview capabilities that we'll lift at GA. We also have things like configuration of custom readiness and liveness probes. So those are just things to be on your radar. And then the last thing I wanted to cover before opening it up for questions, if anybody has time to stick around, we have a Discord channel that's public, so feel free to join there. We have great channels for Dapper, we have great channels for Kata, for general questions, documentation, suggestions. We have a mailing list, so if you wanted to join and just be notified of any major changes or new features that are available. And then last but not least, as I mentioned, we have our public backlog where you can make feature requests and also take a look at existing issues to see if there's any resolvable problems that you run into that we've already fixed. So that's all I have. I would love to take any questions with the 0 minutes we have left. But if y'all have if you're able to stick around, please do.
Well, sorry about that. I still needed to unmute myself and try to be very delicate about it. Caught on camera. Thank you very much, Kendall, for giving this awesome insights in container apps. I still have to admit that I'm still trying to wrap around it and find use cases within my virtual desktop environments, because it feels like it's very focused on web and API-driven applications. And I have to admit that I'm still struggling with some legacy client-server facing applications. So will there be opportunities in the future to also migrate those kind of legacy applications to container apps? Or is that a bridge too far?
Yeah, so I think it's a good question. I think it speaks to the line that we're trying to draw, which is, we don't want to boil the ocean and try to do everything. And we have to think about what the value is from a platform as a service capability. So we get a lot of those questions even for customers who say, hey, I'm running on Kubernetes, like how can I migrate to Azure Container Apps? And a lot of it comes down to like, what features and capabilities do you need on the underlying platform to be successful? So I mean, hypothetically, other than Windows containers, like we really should be able to support any kind of container image that's supported on Kubernetes. So like if you had a monolithic application, if you can containerize it and run it successfully, we should be able to support it on container apps. There shouldn't be a big differentiator there. I think where it comes down to is like, what kind of access do you need to the underlying node? Do you need GPU support? Do you need Windows containers? So I think, do you need to bring your own service mesh, right? Like it's a much more complex situation when it comes down to that. So I think if you have the app portability aspect of a container, as long as you can get your app into that, then you're at least the step, that's step one. And then I think the next question would be, what kind of capabilities does this need to function? If it can do it on AKS or Kubernetes, you're probably 50% of the way there. Then it just becomes, what features do we choose to expose? And how do we make sure that we don't boil the ocean and try to implement every single thing that Kubernetes does? Because likely that will then lose some of our target audience, which is simplifying this experience. So yeah, it's a great question. Yeah.
All right, thanks. Yeah, and I also have some questions from YouTube, and I guess this first one ties in a little bit to the question from Esther. So we had a question from Andrew McCallum, and he's asking, are there any recommended use cases for Azure Container Apps, like best practices, or how or where to use it? Like, who is it aimed for? Who's going to use this technology?
Yeah, so I mean, I will say I do think it goes to, let's see, let me find the slide. I think it goes to this slide, right? So like when we look at microservices, especially in Azure, Azure Container Instances doesn't support service to service, or service discovery. It doesn't support auto scale. So I think it's really for customers who want to run microservice-based applications or container-based applications, but might not have the ability to run and manage Kubernetes themselves, right? We have small teams who might be using Docker Compose, and they're looking for a place to land. I think that's a really good use case. I think if you're doing event-driven processing via Azure Functions and want a platform as a service that sort of manages the scalability and provides a less opinionated framework, I think that can be a good fit here. But yeah, I think it's really anyone looking for a managed experience that allows them to run multiple containers that have some interoperability and intercommunication. So hopefully that helps. I think that there's still some work to be done, I think, to frame out, when would a customer use what? But I think that this is a really good entry point, especially if customers are unfamiliar with Kubernetes, but want the portability and like the DevOps benefits of containers and don't necessarily have the skill set to go create their own managed ingress and create their own, use a service mesh to do traffic splitting and figure out how to do their own authentication mechanisms or deploy their own Helm charts, right? Like we simplify a lot of that experience through this platform.
Yeah, I guess you're targeting a big group here, so that's fine. So another question, it's from Jason Haley, and well, also Robbie Pott asked pretty much the same thing. He says, I know Helm is Kubernetes, but any thoughts on how we could get something like a WordPress Helm chart running in container apps? Or are Helm charts coming to container apps anyway?
Yeah, so I don't see Helm charts. There's no plan for that, right? Our goal is to simplify some of that deployment mechanism where customers don't have to learn Kubernetes YAML to be able to use the platform. I think from a WordPress perspective, right, like there are definitely ways you could do it. We don't have any great tooling that you can just point to a Helm chart and basically do a conversion. We do have some community contributions that have been focused around potentially using like taking a Docker Compose and scaffolding a container apps manifest. So I think some of our tooling investments in the future will help to enhance the migration and portability aspects of those things. But right now it would be, hey, I want to run WordPress. I have my WordPress, container image. What are the ports I need to expose? What are the few things that I need to add here? And you should be able to get up and running without the complexity of what Helm does. But I hear the ask, which is, can we provide an easy migration path from concepts we might already be familiar with in Kubernetes? And I think that there's a lot of evaluation and work to be done to evaluate how to best do that.
Okay, thanks. Well, I think that's a great answer. So yeah, Jason will be happy with that.
Well, that basically concludes the questions that we had prepared. And you also already triggered me to come up with some cool legacy-focused use cases. So thanks for that. Thank you very much for taking the time, because we know you have a very busy schedule. So we really appreciate you taking the time and sharing these cool new features with us. So enjoy the rest of the day, Kendall, and looks like the cat is waking up. So
yeah, just a little
perfect timing to switch back to caring for the cat. Thank you very much, and talk to you again soon.
Yeah, thanks.
Thank you. Talk to you all soon. Look forward to working with you in the future on this.
Perfect.
Bye.
And hopefully you will all join us next month again for another great studio hosted session of Azure Thursday. See you soon.
See you soon.
Certain forces active upon the Earth aim to artificially suppress the natural evolution of human consciousness.